All righty. Let's see if we're up and running. I don't have my glasses on. That's a mistake. All right, I'm going to assume it's recording. A little makeshift classroom here on our day off. All right. And remember, you got to get 4 more right on Friday. So here's some of the stuff we practiced in class yesterday. And I thought I'd just do one of each type. And hopefully, you put in the time, you'll see your scores go up. All right, so let's start with the following relation: x squared plus 8x plus y squared minus 6y, and we'll set that to 56. You pause the video. I think you know the drill. I think you know what I'm after. So we'd like I think eventually a little sketch here, maybe even talk about domain and range. And this is what we practiced, so have at it. And I'm just going to do the problem now, and but you take your time with it and see if you get what I get. All right, so it's Pythagorean relationship, and I know how to express x squared plus 8x. It's another way of saying that calculation is x plus 4 squared minus 16. That's going to become the side, x plus 4 is going to be side of one of the triangle we could draw. And we have another Pythagorean square area to find here. Y minus 3 squared is the area of that side length. And of course, to make it the same calculation, I've got to get rid of the 9 units that really come out of this binomial squaring process. And if you move 16 and 9 to the other side and add to 56, you get 81. That's a square area. We've got x plus 4, so what we have is x plus 4 and y minus 3, giving us a right triangle with a radius of 9. Because as this moves around and gets like the hand of a clock, then all of these square areas take on different size values, but those square areas still have to add up to 81. So the center, -4, 3. So if you put in a -4, there'd be no square area coming from the base. And if you put in a 3, there'd be no square area coming from the altitude. So what do we have? We've got -4, 3. That's the center. And so let's just take the x value, -4. If we move to the right 9 units, well, that gives us a 5. There's no altitude to drawing that triangle, so that would still be a 3, but that's the x value. If we went 9 backwards, that would be -13. That's the x value when y is 3. That makes an equality in this calculation. So what's the domain? Well, my x on the left is -13. My x on the right is 5. And then all these x's in between, either less than or equal to 5 or greater than or equal to -13. All right, almost done. So let's put a 5 in here. Now let's just get it. Let's get this isolated a little more. Y minus 3 squared. Okay, if I put a 5 in here, 5 plus 4 is 9. Let's do it with the finger. No, can't do it with the finger on this board. So if I put a 5 in there, I get 9 squared. Now 9 squared is 81. So what number can I put in here that, and we know 3, gets this equality. So some other number besides 3, think about it. If you square anything, right, you're basically getting positives. And 81 plus a positive can be awful hard to make it equal 81. So that's why we have a restriction here for our x's. Because once you exceed 5, or once you get smaller than -13, you already got more area in the triangular relationship than you can possibly have. So that's the domain. The range, of course, would be doing the same thing with the y values, and that's a pretty complete look at the circular relationship. All right, so let me erase that. All right, this is a little bit of a different kind of whiteboard. Okay, so what else do we have? Well, we've got 2 kinds of quadratics, x squared plus 6x. Let's set that equal to about 11. And let's set x squared plus 6x equaling, let's put in something that has an integer answer. I'll put in a 5. 25 and 30 is 55. Now, when you get integer answers, you don't have to complete the square. You can do factoring. You don't know that yet. The only way you know that is to set it to 0. Okay, we set it to 0 and we then look at, can we factor? And you can already see 5 and 11. Right, 5 and 11 certainly can be made to equal 6 with what? An addition and a subtraction. So there you go. You want to have that skill, which tells you that an x value of 5 or an x value of -11 satisfy the equation. 25 and 30. Yeah, if you put a 5 in, you can see that quickly. 25 plus 30 is 55. All right. And so you want to be able to have that factoring skill. It gets used all over the place in mathematics. But a problem like this, you know, the factors of 11 are 1 and 11, and I don't see how I can get a 6. So one method that always works is putting the quadratic in the ax minus h squared plus k formula. I don't know if I'll call it formula, but graphing form. And that it's not going to be hard to solve. You're going to take k away, you're going to divide by a, you're going to do the plus minus square rooting, and you're going to add h. When practiced, it gets pretty quick and easy. So what am I saying? I'm saying that whatever quadratic you have, when it's set to a constant, if you put that in graphing form, even if it's a more complicated quadratic, then you've got that inverse operation at your fingertips. And why am I picking this? Because you just did it in the last problem. X plus 3 squared minus 9. That's that calculation. That is this. -3 gives us a height of 9. Well, I know that there are some real answers that hit a height of 11. I mean, that's a height of 9, right? So there's an X on this side, and there's an X on that side. And we can always get it pretty easily by doing what? Those inverse operations. And you don't have to, you know, on your desk, you don't have to copy every, you got time issues here. I'm trying to get you to think quickly and think well. So what are you going to do? You're going to subtract, or add 9, sorry, there's 18. You're going to do what? So that took care of that. You're going to do the plus minus square root of 18. That's going to be that. And then you're going to subtract 3. Addition of 3 becomes subtraction of 3. Now, it would be nice if you saw that as -3 plus or minus square root of 9 is 3 root 2. Now, it'd be nice if you wrote it that way. That's the simplest way to express it. Because you know what the square root of 2 is. I've asked you to memorize it. Oh, yeah. Did you? Yeah. -3 plus 3 times approximately 1.41. And that gives you a feeling for the number without a calculator. And of course, it's plus or minus, and I discriminated against the minus sign. Forgive me, minus sign. All right. So that's what we practiced. And you're seeing all these questions on it, right? I'm not hiding anything. This is a language. I'm good at the language because I've been doing this for how long? Right? So I'm trying to get you to do it for as long as possible, because that's why teachers know what they're teaching. Repetition. All right, what's another one? Well, there's all kinds of calculations coming your way. All right, let's just leave this at y, for instance. Okay, it's 2 points, for God's sakes, if you can just graph this. And we said there's 3 things you do in class. And what's the first one? You're pausing the video, right? What's the first one? Then what's the second one? Then what the third one? You should be able to answer that right now. All right, so what's the first one? Shape. V shape. What's the vertex? Well, the x value we need is the one that makes 0, because distance, the smallest distance you can travel is 0, and this has a minimum. And I hope you see that 7. And if you put a 7 in, you should be able to do the math to find the y value, 9. And then you're looking for a y-intercept. Y-intercept is when x is 0. 0 is to the left of 7. All right, so if you put a 0 in, you get 3 times 7 plus 9. And if you don't make a mistake with that, you get 30. And it's nice to check the slope of 3 to 1 here. 20 minus 9, or how much does it take to go from 9 to 30? Well, you got to go back. You got to go up, what, 9 to 30, 21? And how do you get from an x value of 7 to 0? Well, that's -7, which means that the slope on the left side is -3, and the slope on the right side, well, if 0 is 7, then 14, the symmetry of this. How do you get from 9 to 14? I'm sorry, from well, I didn't get the y value. I didn't put the x value. 14, 30, right? There's the symmetric point. Excuse me. How do you get from 9 to 30? Well, you go up 21. How do you get from 7 to 14? You go up 7. Well, that means that this is going up at 3 to 1, whereas this one is going down. And I think that arrow confuses people sometimes. I'm going down at 3 to 1. I'm going up at 3 to 1. So what discussion does that lead us to? Piecewise function. And I'll be asking that on Friday. So how do you write this on a piecewise function? Well, you got to know whether it's V-shape up or V-shape down. This was V-shape up, so that left side is the decreasing. So we'll start there. Minus 3x minus 7 plus 9. But that didn't go on forever. Remember that 7? That's the x value. Right? And then I'm not going down when x's are bigger than 7. I'm going down on x for the x's that are less than 7. I'm going up. And we got to include that point. So I'll just put an equal sign with this one. If you play the video and you think about this, you should be able to come in on Friday and you should have that, which means you learn something. And I'm grading you on what you're learning. All right, so now that we got that, I shouldn't erase it yet because you should anticipate the next question. So the next question is when this V shape, which we know has a y value of 9 as a minimum, can't get smaller than that because this is kicking out positives. And if you multiply a positive times a positive, the influence on that amount is going up at 3 to 1 ratio. So let's put a number in that's bigger than 7. How about I put in, well, we already saw 14 gave us the answer. So let's say set this thing to 14. Okay, so how do you solve that? The quickest and easiest way. What's the quickest and easiest way of solving that? To use the pieces. So since I got a whiteboard, I'm going to use these pieces and I'm going to erase this part because I've got the calculation and I'm setting the calculation equal to 14. We already know our answers are 0 and oh, I wanted a height of, I'm mixing my x's and my y's. So let me go back here. So excuse me. I know you already started this problem, but I think I meant to say 30 so you could see the answers of x equals 0 and x equals 14. That's what I meant to do. All right. So I apologize. I know you already did some work and it's probably good work, I hope. But how would I set this thing to 30? Well, again, I'd erase that part of the piecewise function and I'd set each of the pieces to 30. All right. So let's solve this one first. Subtract 9, 21, divide by 3, 7. Add 7, there's one of your answers, 14. That's the one on the right, on the increasing side. On the decreasing side, which is what you found early on when you found your y-intercept, so you're setting this thing to 30. All right, what are you going to do? You're going to subtract 9, 21, going to divide by -3. That's -7. Now when you add 7, you get 0. Okay, and we're finding table values. You know, we got a big sketch and we're just picking apart that big sketch and finding, hey, what x gets me what y. That's the way to, probably the easiest way to handle absolute value. How do I know that? Because I've been doing it for 45 years and I switched to this. I used to do it a different way, textbook method. And, there are some quirks with that. There are some things that really, I'm not sure you have enough time to process in a first year or even in algebra 2 or at pre-calculus level. I mean, there's so many things to cover. That's the quickest and easiest way to deal with that. All right. So what else do we have? Well, another sketch. Y equals 2x squared plus 20x minus 11. Okay. And you're going to pause the video in a second, but again, what are the 3 things? In what order do you do them in so that this is a quick and easy process? Now you pause the video, all right? And then you go ahead and do it. And then you see if you follow kind of the line of reasoning that I'm going to present right now. First thing, shape. Second thing, the table value necessary for the vertex with an X and a Y. I've got an equation here that if I can find the X, I can plug it in to find the Y. And what did I hope came to your mind? Minus B over 2A, which is 4. So I now know -5 is the X value I'm looking for. I also know that the Y-intercept is on this side. Maybe that's better to do right now, so you don't have to think about it too much. Which side is the Y-intercept on? 0 is bigger than -5. So now we just have to find two Y values. Honestly, we already have that one, right? -11. So the only thing we're missing for 2 points on the next test, the Y value. So we'll plug it in. 5 squared, -5 squared, 25 times 2 is 50. The next number should be -100. -5 times it is, and then -11. When you put these together, you always get half the middle term, -11, so -61. So that's worth a little, 2 points. All right, so not that I was intending to ask this, but I also asked, write the equation of a quadratic given the vertex and another point. So how would you do that? -5 -61, so X plus 5 squared -61 correlates those, and this is the minimum because this is kicking out positives, upward influence on the Y values. How do I get from -61 to -11? I think I got to go up 50 units. If I went over 5 units from -5 to 0, well, that's a change of 5. If I square a change of 5, I get 25. But I want 50. I don't want that 25. And there's your 2. There's your X squared plus 10X plus 25. There's your -61. And that should get us what we started with, which is Y equals 2X squared plus 20X. 50 -61 -11. That's what we started with. So it's just kind of like a rotating around. One thing leads to another, and going the other direction brings you back to where you started from. And I'm hoping that that's starting to make more conceptual sense as well as mechanical. All right, so what else do I have? I'm not sure. My memory's so bad. Let's just do another one of these. X squared plus 6X equals 3. All right. I don't think you can factor it. Be nice if you could set it to 0 and find some numbers that multiply out to be 3 that connect to 6. And if we put a coefficient here bigger than 1, that gets a little more complicated as a discussion. But let's do this first. So I can't write that as a product. So what do? Well, I hope this is becoming second nature to you. So we add 3 to 9, we get 12. We take the square root of 12, which is 4 times 3. So I'm going to write it as 2 root 3. And then I'm going to subtract 3 and I'm done. Okay, so there's some practice. I'll upload that. Maybe I'll do one tomorrow. I'm going to put this on Canvas right now. And, you can look at your answer keys. Numbers should talk to you. You look at the original question, you look at an answer, sometimes you can just figure out how to do it without any work. All right, so I'm going to stop this now, and maybe I'll make another one tomorrow.